When developing large language model applications, should we use RAG or fine-tuning? I believe many people are curious about this. First, we need to clarify the difference between RAG and fine-tuning. RAG, or Retrieval-Augmented Generation, does not modify the base large language model. Instead, it adds external knowledge to the model and uses this additional information to answer user queries. In contrast, fine-tuning modifies the base model itself by incorporating specific knowledge, resulting in a new, fine-tuned model that answers user queries based on the updated model. So, these are two fundamentally different approaches. Simply put, RAG does not involve training the base model, whereas fine-tuning requires training the model. Based on these differences, we can analyze several scenarios to determine when to use RAG or fine-tuning. The first scenario involves dynamic data. Dynamic data refers to data that changes frequently, such as business data in enterprises. In such cases, RAG is the more suitable option. If we were to use fine-tuning, we would need to retrain the model every time the data changes, which would be highly inefficient. Using RAG, we don't need to worry about how often the data changes. We only retrieve the required data when needed. The second scenario is customizing the model's capabilities. For example, if we want the model to communicate with users in a specific tone, such a capability may not exist in the base model. In this case, fine-tuning is more appropriate. For instance, we might require the model to read financial reports, extract specific content, or interact with users in a sales-oriented tone. The third scenario is hallucination. Both RAG and fine-tuning can help reduce hallucinations. However, in terms of effectiveness, RAG is generally better at addressing hallucinations. The fourth scenario is explainability. Sometimes we need the model to provide explainable outputs, such as explaining why it generated a specific response. From this perspective, RAG is superior to fine-tuning. Fine-tuned models often behave like a black box, making it difficult to understand their internal mechanisms. When issues arise, it's hard to trace why a specific word or phrase was generated. In this case, RAG is a better choice. The fifth scenario involves cost. From a cost perspective, RAG is more favorable. With RAG, there's no need to train the model. We only need to construct the workflow using engineering methods. Fine-tuning, on the other hand, requires collecting data, performing the training, and iterating if the results are unsatisfactory, which increases costs. The sixth scenario pertains to general capabilities. If the application relies on the general capabilities of a large language model, such as conversational skills, RAG is a better choice. Fine-tuning fundamentally changes the model, which can lead to a loss of some original capabilities. This phenomenon is often referred to as model forgetting. Another scenario involves low latency requirements. In situations where low latency is critical, fine-tuning becomes the preferred option. RAG typically involves multiple steps, such as retrieval and ranking, which can take additional time. For scenarios demanding extremely low latency, fine-tuning is the better choice. Finally, there are resource-constrained scenarios, such as smart devices with limited hardware. In these cases, we often need to use smaller models, which generally have weaker general capabilities. However, with fine-tuning, we can optimize the model for specific tasks, making it more effective in resource-constrained environments. Of course, in some cases, it's also possible to combine RAG and fine-tuning. These are the factors to consider when deciding whether to use RAG or fine-tuning.